I'll be in here period 7. Yeah. Okay. What questions do you guys have on the derivatives packet? Here. The derivatives packet that you guys were working on last night for homework, the odds. Ready, set, and anything, go. Katrina.
9.
Okay, what else? 1. Okay, what else? Sarah. Ella. Okay, what else?
7.
Oh, 7? Yeah. Okay, going once, going twice? Start. If possible, yeah. Okay. Yeah. Anything else? Alright, so long story short, we're going to go fast as we can through 13. You guys might have more past that, but frankly, I'm not sure we can really get through more. 2 of these questions, once again, are the ones that are in the video for period 6, so I'm going to go very quickly because, once again, they're literally online and I explain them. But maybe you guys forgot that I said that, or didn't believe me when I said that. Sometimes I say that and I don't get through more. But with 10 extra minutes of class, of course we got through more. Alright. Number 1, real fast. I graphed the points for period 6 yesterday, literally the 2 points in the table that we knew, this one and that one. They were asking what value at x equals 1, because that was x equals 2. What value of k by I dt, they didn't say that, but that's what's meant or implied. Where must k be in order to make the function, the continuous function, go through the x-axis twice, have 2 zeros? Question. If k was a negative number, would it have to go through 0 at all? Nope, it wouldn't have to go through 0 at all. If k was at 0, would it have to go through 0 twice? No. What must k be in order for the function to have to go through? It must be above, aka positive, aka. Number 3. Global min. You guys know that. Global min means what? Absolute min. Absolute min, what do? Find the derivative and find the critical numbers. The critical numbers setting equal to 0. We were able to find using factoring. We end up with x equals 4 and negative 2. Why do I have the 4 canceled out? It's not in the interval. So therefore, I go ahead and make a table. I plug into the original function, just like my forever card says. I plug in endpoint negative 3. I plug in critical number negative 2. I plug in endpoint 0. The name of the game at that point is simplifying. Question?
Yeah. So for this one, it says find the global minimum value, but then for 2 it says the minimum values like as well. But for 2 you had to plug in and solve for y, and for 3 you just wanted the x. So how would you do that? Like how would you distinguish between?
Oh, I answered it wrong yesterday. I was doing it too fast because we were trying to bust through more. What were the values? Hold on, double checking real fast. I get 27 thirds, that'd be negative 9. Negative 9, negative 18. Negative 18 and 24 is 6. 6 plus 2 thirds, that'd be 18 thirds plus 2 thirds is 20 thirds. That'd be that one. Negative 2 would be negative 8 thirds minus 12 thirds, negative 20 thirds, negative 20 thirds plus 2 would be negative 18 thirds, which would be negative 6, which would be 10. And then at 0, 2 thirds. Thanks, Katrina, for checking that. The correct answer should be C. The reason being is the absolute min. If you guys look at all 3 of these values, the absolute min is the last one. I was going too fast. It happens. It is at x equals 0. Of course, they have that x equals 0 as an option, but they wanted the global minimum value of, and the value of always indicates the y value. Thanks, good. Always indicates the y value. That was number 3, true?
Mm-hmm.
If my pages load, I'd be able to double check that answer, but I have full confidence that that is right.
Yeah.
Okay, thanks. I appreciate it. Number 5, good catch. Good catch. Number 5, simple quotient rule, plug and chug. Simple quotient rule, plug and chug. We're trying to get the equation of the tangent line. Y minus y1 cosine times x times x1. So by doing a quotient rule, by plugging in x equals 1, you end up with a slope of, which is the derivative value, -5. I plugged in -5, I simplified, and I got b. Quotient rule, if you need to double check it, bottom d top minus top d bottom all over bottom squared. You should end up with -5. Number 7, you guys tell me, what should you have done?
Taking the derivative.
And put a differentiation, it's as simple as that. So I'm not going to do the entire thing, but suffice to say, when you take the derivative of 2x and y, what should you use? Product rule. Second d first plus first d second, which would be dy dx. Remember the derivative of y? You still have minus 3y squared, derivative of 6y. You have another dy dx equals 12. There are multiple ways you could simplify it.
Yeah, equals 0.
Thank you. I'm talking instead of writing what I'm thinking. If you want to get dy dx by itself, you can move it multiple ways. You can move the dy dx's to the right and then keep everything to the left, or you can move everything else to the right and keep the dy dx's to the left. Long story short, the one question I got from someone this morning, they had done their work perfectly and they just moved it a different way than the answer key. Kiddos, are these two the exact same thing? Why or why not? Exactly. Everything in the right one has an opposite sign than everything in the right on the left one. If it has the opposite sign, how can you check to make sure it's right? Just multiply top and bottom by a -1. And what's it going to do to all the signs? Flip them. Yeah, it's going to flip all the signs. So then we'd have the exact same answer. So just keep an eye open. If you solve things correctly, they should match. You just might have to do something to kind of change things up. Number 9. You guys tell me, these intervals, where do we get intervals from? Something called? Bound? Okay, maybe that's not the right question to ask. Maybe we don't have enough.
Is it unit circle?
No. We get intervals from sign charts. Now why are we doing sign charts? Because I see decreasing and concave up. So decreasing and concave up. Where do we look for decreasing, kiddos? Which derivative?
First.
The first derivative. So you can go ahead and take the first derivative, which hopefully you guys did chain rule correctly. And set that equal to 0. And yes, granted, to solve that, you will need the unit circle. However, for concave up, we're also going to need the second derivative, which we're going to end up with -4 cosine 2x after doing lots of chain rules. Yes, we'll have to find the pips for that. We have to do a sign chart for each one. Set it equal to 0 when we divide by -2. When we divide by -2, we'll just end up with sine 2x equals 0. Over here, we'll just end up with cosine 2x equals 0. Going to the unit circle, when is sine 0? 0, pi, 2 pi, 3 pi, etc. Give me 1 second though, because we haven't totally solved yet. Cosine of 2x is going to be at pi over 2, 3 pi over 2, 5 pi over 2. Kiddos, we haven't solved for x yet. How do we solve for x? Divide everything by 2. And to divide everything by 2, those angles change just a little bit when we solve. So divide by 2, divide by 2 in the top one, x equals 0, pi over 2, pi. You notice 3 pi over 2 will be outside the interval if you look up above, so we cross them out. So those are the critical numbers for the first derivative. And then if we divide the bottom by 2, we end up with pi over 4, 3 pi over 4, 5 pi over 4, if you notice, is beyond pi, so we ignore him. You have a choice here, since they asked for decreasing and concave up. We can make one huge sign chart, if you would like, and we could put in all of those numbers in the sense of you cut off at 0 and pi over 2.
Just
0 and pi. We have pi over 2 here. We have pi over 4 and 3 pi over 4. And we could check F prime and F double prime for each interval and just make one big old sign chart with everybody going on in there. Or you can make two separate sign charts. Both of them work. Both of them are good. Since I already have the work done and time is short, I'm just going to keep going on this if that's okay. You guys know what I'm doing with the sign chart, right? I'm going to plug in betweens. Now, if I had a calculator, I would love to plug in like halfway pi over 8 and check that value to see, hey, what are the signs in the first second derivative. However, pi over 8, is that going to be fun to plug in? Actually, it might not be too bad, to be totally honest. Don't I have a 2x I'm plugging into? 2 times pi over 8 is pi over 4. So the name of the game is can you plug and chug carefully. The name of the game is can you plug and chug carefully. People that did this and did a sign chart, do you know what f prime was for 0 to pi over 4? Or 0 to pi over 2? Be the same answer. The first derivative, 0 to pi over 2, if I plug in pi over 8, that'd be pi over 4 root 2 over 2, that'd be a negative for the first derivative. That'd be a negative for the first derivative. If I plug in the next interval, I still have a negative. I think I have negative for everybody. Double check them real quick. Between 0 and 3 pi over 4. I haven't done second derivative yet. But 3 pi over 4 times 2. Oh, that'd be 3 pi over 2. I apologize. These ones will flip to be positive. I missed that. You were multiplying by 2x when you plug in. For the second derivative, when you plug in 0 pi over 4, pi over 8, pi over 4, that's going to be a negative as well. That's concave down. That one doesn't work. So I have decreasing and concave down. That's not what I want. From pi over 4 to pi over 2. Plug in pi over 2, pi over 2. It's decreasing, that's true, and that one's going to be a positive or concave up. If you guys notice, we don't even have to test these two because those are where the first derivative is positive. We need decreasing, so we can ignore that whole side altogether. And once we figure out this guy's not the right one, well, hopefully that one is. And then, Alan, you said you had the right answer. It's D, right?
Yeah.
Good. No judgment. So, guys, unit circle. You can divide you on that one. Pretty good. Number 10, so I'm not going to go through the entire thing, but long story short, I would rewrite F to be sine of x to what power, kid? So we bring down the 1/2, negative 1/2 times 2. How do we do that? Which one did you think? 1/2 is the negative 1/2. Oh, remember you keep the inside the same. Chain rule says bring down, keep it the same. Oh. Then times u prime. Does that make sense? That's why I do this. Letter C. This is one of those ones like in the video, the AP reader and sound we're talking about. They give you an idea, but they do all the work. Why is this awesome in this one, kiddos? They already give you the second derivative. You have no deriving to do. Kids say, look at the second derivative. They give you the second derivative. So kiddos, how do we figure out points of inflection? Yeah, we find the pips by saying second derivative equal to 0 or DNE, but nothing will not exist in that expression. And that's going to happen at x equals 2, negative 3. Ooh, when's cosine going to equal 0 in between negative pi and pi? Oh, negative pi to pi. Thank you for seeing that. Negative pi over 2 and pi over 2. Negative 90 and 90. So we can go ahead and make a sign chart, starting at negative pi, ending at positive pi. Is this a calculator question?
No.
So much more fun. We could plug in negative 3, because that's a little bit above negative pi. We could plug in negative pi over 2, which would be a little bit higher than that, because it's 3 over 2. We have positive pi over 2 being here. That'd be 3 over 2, which is 1.5, and then we have 2, roughly. All we're trying to figure out is, how do we know if a pip is an actual pip? When concavity changes sign. Good. When concavity changes sign. So it gets a little messy here. The easiest one to check, I would say, is in between negative pi over 2 and pi over 2, because that's a 0, right?
Yeah.
So we can test at 0. Plugging in 0, we get a negative, we get a positive, and then we get cosine of 0 is 1. So that's going to be a negative. I knew that for this whole interval. Between pi over 2 and pi, this gets a little messy because of approximation. So you have to think about this one as being 1.5-ish, approximately. This one is being negative 1.5-ish. What's an angle that normally comes after pi over 2?
3
3 pi over 4 usually comes after. So then we think about 3 pi. Pi is approximately what, guys?
3.
It's 3-ish, right? But higher. So if I do 3 pi over 4, so 3 times 3 would be 9-ish. 9-ish over 4, but bigger than 9? Isn't that bigger than 2? So then I could say, okay, well the test is to test 3 pi over 4. That would be bigger than 2. Something would be smaller than 2. 2 times pi. 2 pi over 3 is what I was thinking of. But 2 times pi.
Would this be a calculated problem? Or no?
They didn't say
Yeah,
GCs. I feel like it should be a calculated problem. I feel like it probably would be a calculated problem. But we're just saying, what if not? If it was a calculated problem, you would just graph this, look at the zeros, and see how many times this function goes from above to below. That's all you'd have to do if it was a graphing calculator problem. How many times does it go from above to below? Plugging in 3 pi over 4, that's 9/4, a little bit more than 2-ish. That would make this one positive, positive. Cosine is negative. That would be a negative value. Less than 2, long story short, that one would be a negative. That one would be a positive. Cosine is negative in the second quadrant. That would be a positive. If I come over here, negative 3 pi over 4. Cosine is a negative third quadrant. Negative 3 pi over 4 would be negative 2-ish. Negative 2-ish, that'd be a negative, and a negative times a negative is a positive. And then somewhere in between negative 3 and negative pi over 2 would still be in the third quadrant. Cosine is still negative. Again. Oh, negative 3, so I was doing negative 2. That was negative 3 pi over 4 plugging in. Something a little bit more than 3, but not quite high. Cosine would be 3 pi over 2, 3 times pi is 9, negative 3, 4, still third quadrant, negative. I think that would be a positive also. Is that right? So we have 1, 2, 3?
Yeah.
Okay. That was a mess. Blech. I haven't seen very many of these really nasty approximating ones come up very often. If you guys are like, there's no way I could do it, this would be like 1 out of the entire thing. We can let go of 1, but if this is a calculator problem, you guys should be on this, because we graph that second derivative, look for aboves to belows, and it would occur 1, 2, 3 times. The graph would go from below and above the axis. Alright guys, that was messy. Hey, this one's your graphing calculator. But you don't need it. What theorem are you using in this one, kiddos? Continuous and differentiable sounds an awful lot like Rolls or MBT. But kiddos, could it be Rolls if those two aren't the same? Meaning one's 3 and one's -6? It's not rolls, so it must be.
MBT.
There must be a place, f prime of c, where f of b minus f of a. So I'm using g's now, sorry. Nice thing is it's not an FRQ, so they wouldn't be able to see what you did to get there. But g of b minus g of a all over b minus a, which would be negative 6 minus 3 all over 5 minus 2 is 3. Did I get negative 3? Wait, you don't even need that.
You just have to know the.
Just no MVT. That's true. Why is rolls not true? Because they aren't equal. That's not true. What's that last one saying? G of C. Is that MVT anywhere? Corey, come to the table and you're going to pick up 1, 2, 3, 4, 5, 6, and the stapler ended up somewhere. It's on my desk. Ah, Sarah Bickle has it. That's the new packet. We're just going over questions on the derivative that you guys got yesterday. So, is IVT true, kiddos? Why is it true?
The number of things.
Yeah, must hit 0 if it goes from a positive to a negative. Check. IVT. Final answer? Rolls doesn't apply to IVT, MVT does, therefore 2 and 3. Letter T. With that, kiddos, we got to the end of the ones that you guys were asking.
Can I ask one?
Free response.
Grade 15.
Oh, now 15.
I did ask 15.
Yes.
What are you gonna ask? Place F prime of A. Oh, hey, wait, there's a graph. What's this a graph of? This is a graph of y equals f of x. How do I know that? It's an F. Kiddos, someone tell me something about the behavior of F. Oh, you know the behavior. What am I talking about? What clues?
It's decreasing.
Increasing, decreasing, and concave up, concave down. So this one is decreasing and concave up. What do I know then about my derivatives? F prime is negative and F double prime is positive. So you could say F prime is negative and increasing, or you could say F prime is negative, F double prime is positive. And then, wait a minute, what's F of A?
F of A is at 0.
Is 0. So I have a negative, I have a positive, and I have a 0. Okay, those if we order a negative and a positive and 0, shouldn't the negative go first?
Yeah.
Then the 0? Then the positive? Which one matches?
B.
Okay, sorry, I thought I heard E and then I thought I heard D and then I thought I heard C.
B.
It's B. It's the only one that goes F prime and then F double prime. Corey, you did say free response, but what part of it? Part D?
Yeah.
Okay. Part D is messy on the FRQ. Part D is messy on the FRQ. You guys figured out in the above intervals, you had to look at the derivative for A, you had to look at the second derivative for B, you had to look at, you could have used the first derivative or second derivative test for relative extrema for C. Long story short, this graph, and I was actually like kind of graphing it yesterday, pretending as though K was 0 when someone was asking me this one. I think you guys figured out where was the local minimum of this graph. And C, what'd you find? 2/3, was that the x value or the y value?
Yeah.
Okay, so when x is 2/3, did anybody figure out the y value?
It was.
Yes, it was down here. What was the other critical number for A?
2.
I think it was a negative number, wasn't it?
Negative 2.
Negative 2. Okay, there you go. Here's our function, if k is 0. Here's our function if k is 0. What is the only way that this function can only cross through the axis 2 times? Because this one's crossing through 3 times. If k is 0, it crosses through 3 times. How can this only hit twice? Isn't k a vertical shift? So if k is a vertical shift, where do I want this parabola to go to only hit twice? Up? whatever that minimum is, or down whatever that maximum is. Sorry, you guys can't see me really, can you? We either go down to the max, it's going to hit only twice, or we can go up to the min, it's only going to hit twice. So the long story short of it is you just need to figure out what those y values are as far as what is f of -2 when k equals 0, and what is f of 2/3 when k equals 0. And that's going to tell you the shifts that you would need to do in order to offset those minimums and maximums. If you plug in -2, I did it yesterday, I think it ended up being 8. Is that right? Okay. So then if it's 8, then I need k to be, and I need it to come down 8. Does that make sense? I need to shift the entire thing down 8. Or, at 2/3, it was a nasty decimal if I remember right. It was something yucky.
-40 over 27.
Thanks. You guys agree? So then k is going to equal the opposite to shift it up. Now kiddos, good news about this one, this was very pre-calish, even though the calculus would help you find the maximums and minimums, and that's what A, B, and C did. But in letter D, if you want to, just real quick for your own safety and well-being, just put little parentheses around that. That's not going to show up on AP. Or it shouldn't. It shouldn't show up on AP. Alright, Corey, we answered your question. Kiddos, go ahead and pass that derivative packet up. We did get a lot done in that. We did get a lot done in that. Let's go peek at the limits.
Oh.
Let's go peek at theorems. Some of you guys got a little stuck on theorems, especially that IDT, NBT rolls one. If you guys were absent yesterday, you just have to tell me when you do turn in. Did I was absent? Did anybody who was gone yesterday not get the derivatives back again? Anybody else who was gone yesterday? Okay.
The dress.
Sure, but I didn't think about it. If you can't sleep that one day, you can also use it out. Oh my goodness, hold on. I have my high school in my head. 9825 Woodley Avenue, North Hills, California, 913. Alright. So, theorems, hypotheses, NBT, IBT, EBT. What do you guys think these pages are going to be about when we get to them? Oh, there you go.
Yeah, but there's other stuff.
Go team. Long story short, IBT. Some of you have come to me asking about this one, but many of you guys have it, and you still don't like IBT. When you're studying your forevers, et cetera, you're like, this thing's gross. There's like f of c's equaling a's, and like f of a's and f of b's. Remember, intermediate value theorem is the same thing as in between y value theorem. And remember, y can equal different things. It can equal f, it can equal f prime. But in between y value theorem, that's the intermediate value theorem. Value of, max of, min of, like Alan brought up earlier. Or actually, Katrina, I don't know, both of you guys. You're looking for the y values. Value is showing or indicating the y values, intermediate in between. So intermediate values is this really snazzy way of saying, hey, the function goes from one point to another point, and it's continuous. That's key. And it's continuous. It's going to somehow have to hit through. Now, guys, the only thing's guaranteed on this theorem for this example, it's going to somehow have to go through, at some point in time, all of the y's in between. So f of c is going to have to be in between the y value it starts at and the y value it ends at. It could go elsewhere, and this one does. It goes below. But it doesn't have to go elsewhere. All we know is there's going to be at least one place where this function hits everything in between. We just used that on a problem. We had a negative, we had a positive. We said, of course, there has to be zero somewhere in between. That's IDT. What's this one indicating? MBT. MBT, you guys know two conditions, continuous, continuity, and differentiable, differentiability. And what is it giving us a clue about? The original function or the rate or the derivative? The derivative. IBT tells us whatever value we're given, that value is going to have to go from here to here, somewhere in between is going to have to hit all the y values in between. MBT says, hey, if we know something about the endpoints, we can know something about at least one derivative, at least one tangent line, at least one instantaneous rate. We can say it lots of different ways. One way that we said it, I think we even put this in our card, instantaneous rate will equal the average rate at least somewhere. When you see instantaneous rate, what do you think of? Derivative. When you see average rate, don't you think of f of b minus f of a all over b minus a? There we go. You have an example down below, but we're moving on to MBT for integration. That's a thing.
Yeah, it's a card.
Yeah, that's in the paper card. There were two different variations of MBT. If we're asking or being asked for the average value, you guys have average value as its own special forever card. Yes, he's that important. Average value of a quantity that you're given or average of the function. And you're given the function itself. There is no rate to that. There is no slope to that. We have to integrate 1 over b minus a. It just says the function value is going to have to equal the integral at some point. In our notes, if you guys want to think about that idea, we really fleshed that out. You can go back to the video of that day. We talked about it. We showed how it works. But the example, this might be good to look at. It's already all solved. You guys don't have to do anything. Let's just see what happens. They ask what is the average value of a function on an integral. We plug and chug into our integral. We solve our definite integral. On this one, they say, sweet, calculate problem. Let's just go to 11/3, or maybe they solve it off to the side. Here's where MBT for integration comes in. When does this average value occur? All we have to do is set the original function equal to that average value and say, hey, it's going to have to be the average somewhere. And Kira, this kind of makes sense if you think about like an average score, like a class's average score on a test. In the sense of, if an average score on a test is like a 75, right? Kids got above, kids got below. Does a kid have to have 75?
No.
Technically, no. Why? Test scores aren't continuous. Just because a kid got a 37 and a kid got a 98, does that mean every single score in between was touched upon by somebody? No, you only have so many students. It's not continuous. But what if you did have a continuous function that did have to go through everything? Through all those scores, wouldn't it have to hit the average because there's stuff on either side? It's kind of like IBT, but taking in a really snazzy MBT for integration theory. Roles we already know about. We have continuous, we have differentiable. The two endpoints are equal, so there has to be a place where the derivative is 0, but roles is really just a special MBT. Roles is really just a special MBT. But to prove roles, you have to check not only for continuity and differentiability, but also for the endpoints being the same. Plug in A, plug in B, hopefully they equal. And they went ahead and showed an example down below of solving. Last but not least, EBT, extreme value theorem. I want you to think of extrema, right? Extrema, because that tells you what the theorem is. Am I trying to help you study your forever cards at the same time? Yes.
Yes.
Don't worry, you have spring break quoting. You can get bonus by even quoting more. Extreme value theorem. Extrema, absolute extrema. If a function is continuous and it's on a closed interval, it has to be cut off. If the function is continuous and cut off, there's going to have to be a highest, there's going to have to be a lowest no matter what you do. If it's continuous and cut off, somewhere it's going to have a high, an absolute max, somewhere it's going to have a low, an absolute. Oops, that's not the absolute min. That's the absolute min. Sometimes it'll be at the endpoints, sometimes it'll be at critical numbers. Hence why we have to test them all in our chart. Critical numbers and endpoints when we're testing for absolute truth. Kiddos, with that, let's get into multiple choice. And if you realize, do you guys realize how few problems are on this week?
Oh, we have two straight ones.
We have 1, 3, 5, 7, 9, and 1 FRQ, true?
Nice.
Aha! 2 FRQs. Okay, I'm a horrible person.
3 FRQs.
Well, I mean, if you do the evens, there are 3. But that's optional, true? Based on time. Alright, where are we going to start? Do you guys want to start with an FRQ this time, or are we going to start with multiple choice? Alright. Number 3. What do we know about G? Continuous. Do we know anything else about it? Do we know differentiability?
No.
So if we don't know differentiability, can we say anything having to do with MDT or roles?
Nope.
Oh, well that's good. So what can we say? IVT is a good one to think about. Which one? A, D, and E all kind of sound like IVT. A, someone can make a mistake on it. Say, of course it's going to have to be 0, and you're right. But what's wrong about A?
You don't know if it's.
Does it have to happen at 0?
No.
It can happen anywhere. D or E?
D.
What is E saying? Help me with this. What is it saying?
That, it doesn't, that it has to be between those two, but it can go.
It's saying that it has to stay between those two. It cannot go above that range or below that range. But wait, guys, we just saw examples. Can't it go below or above and still hit all the in-betweens?
Yeah.
Well, forget E. But doesn't it sound nice?
It does.
It does.
Once you hit it.
This is what makes us kind of doubt that AP reader and the trickiness factor. Alright, we're going to number 3. Alright, what are the clue words? Pick them out. What do you see?
Continuous.
What else?
Differential.
Ooh, we see continuous on the closed. Oh, that's what the theorem says. Differentiable on the open. What else do we know? Are they the same?
No, but it could be an IVT.
Maybe an IVT, maybe an MVT. Probably not a rolls. Wait, oh, well, fine. It's not a rolls. What do we get to cross out? That's rolls, right? Hmm. This is a struggle. Wait a minute. A lot of these sound really good. Read the directions again. Which of the following statements could be
False.
Oh.
Oh.
Well, that changes things a little bit. We just crossed out the false one.
Is that the right answer?
Yeah, that's.
I think there's
Absolute max, isn't that guaranteed by EBT?
True.
Hitting 0, isn't that guaranteed by IBT? Guess what would happen if we did f of b minus f of a all over b minus a, because I'm looking at letter E right now. I see negative 14 over 7. I see negative 2. That number, negative 2 did not come out of random nowhere. That's MDT. I'm pretty sure. Hey, we just said rolls is not guaranteed, right? Both team. You're like half through. Pause! I'll help you at number 5. Isn't there a certain formula for MDT that we can plug and chug into? So all we're going to do is take the derivative of f, set it equal to f of b minus f of a all over b minus a. What are we going to solve for? Find the special x. Love that. So you only have 5 and 7 and 9 and then 2 FRQs? And they're not even real AP ones. They're just kind of like little ideas. Michael, kids, you got this. While it's fresh in your mind, maybe try to do it tonight and then you don't have to worry about it this weekend. Life would be nice. I'll probably be gone by 2:45. I'll be posting it out.
I played this really racist detective. Yeah, I'm also really mean district attorney.
That's some nice section on that lift.
No, but the district attorney's really neat too. And then at the end, one of them, they were both, one of them was innocent, he was in water, and then he took off my mask.
Good job, guys. Good job. Got a lot done.